Welcome, ladies and gentlemen, to this video lecture. Okay, let's take a look at this example. Prove using the definition that the limit as x tends to 3 from the right of 1 over x squared minus 9 is equal to plus infinity. Okay, as usual, what do we need to do? Let's write out exactly what we need to prove. And what do we need to prove? We need to prove this statement. And to be able to prove that, we need to know exactly what this means. What does it mean? We need to have the definition memorized. So for every e greater than 0, there exists a delta greater than 0, so that if x is to the right of 3, but within a delta distance of 3, then f of x should be greater than e. So it doesn't matter what number e we take, doesn't matter how large it is, we should be able to find a small interval to the right of e, so that all the function values is bigger than this capital E that we have. So that is what we have to prove. Let us write out our proof outline. So this is our plan. So we want to show for every E. So we fix any E greater than 0. We must show that there exists a delta, so we must define it. Define delta as something, and it must be positive. What are we allowed to use? We are allowed to use E, any of our previously defined symbols, and here we are allowed to use E. Then we need to assume that x is greater than 3 but less than 3 plus delta. That is because we want to prove this implication. And now here we want to do some work, and finally we want to conclude that f of x is bigger than e. So here is our proof outline. This is our plan of what we will need to do. Okay, so now let's start filling out our details. I'm going to duplicate this page so that we can fill out our proof. So this is now our proof for realsies. Okay, let us start over here. I'm going to delete this, and I'm going to move this down a little bit down that way. What are we interested in? We want to get f of x greater than e. What is f of x? Is 1. Let's write it this way. Consider the following. So consider 1 over x squared minus 9. And this we want to get bigger than this e. So difference of squares, let's factorize. This is equal to x minus 3 and x plus 3. So if we factorize it this way, that is what we get. And we see here this thing, as x tends to 3, we can make 3 from the right. So if we are close to 3 but not quite, then this factor becomes very large. So this guy will become very large. The problem is here with this factor. you see if x is equal to 3, then this factor is a constant 1 over 6. So we want to finally get everything bigger than e. So we have to somehow bound this factor from below. So we have to somehow get this factor to be bigger than some constant. And that will allow us to use this factor to choose our delta appropriately. So let's do that. So same old trick. What are we going to do? We are going to restrict our view to, I'm going to do it over here. We're going to restrict our view to an interval of length 1 around to the right of 3. So we're going to restrict ourselves to this interval. And what are we going to do? We see this thing. What does the graph look like over here? So here at -3 it goes to infinity, so it kind of looks something like that. And we want to find, or we want to have this expression larger than something, some constant. So we want to find a constant on this interval, for example, like so that the graph always lies above that. Okay, so how will we do that? So we restrict ourselves to the interval 3 to 4. So let's say if x is greater than 3 but less than 4, and remember that is 3 plus 1, then what happens? So then we want x plus 3 to be greater than something. So I'm just going to put that in brackets for now. So let's work like so. X less than 3, less than 4. We want to have something with a plus 3, so let's add some 3's everywhere. X plus 3, 7. And now let us divide by everything, and then the inequalities flip. So think about it this way. If we divide x plus 3, that becomes less than 1 over 6. So the inequalities flip around the other way. 1 over x plus 3 is greater than 1 over 6, but less than 1 over 7. And here is the inequality that we're looking for. Did I do that correctly? No, in fact, I did not do that correctly. Let's redo that. So what we're interested here, 1 over x plus 3 is bigger than 1 over 7. And yes, so be careful here when you're working with chains of inequalities and you're dividing by everything. Then be very, very careful. It might be better to do it each one separately, and this one we see that is less than 1 over 6, so that is what we want. So just be careful when working with your inequalities. So this is what we're looking for. 1 over x plus 3 is bigger than 1 over 7 under the condition that x is within a distance of 1 from 3. So remember, now we got to bake in a 1 in our then delta is going to be less than 1, and then if delta is less than 1, then 3 is going to be less than x less than 4. Or let's write it this way: 3 plus delta, which is going to be less than or equal to 4. So x is going to be greater than 3, but strictly less than 4. And so this is going to be greater than 1 over 7, 1 times x minus 3. Okay. So remember, this is under the condition here. Let's label this A. So by A, and by star and by A. So what is star? Let's label this star. So by star, the condition here is satisfied, and since the condition is satisfied, we get that this factor is greater than 1 over 7. Okay. So now, what do we want? We want finally to have this greater than e. So let me think here. What would be the best way of doing this? Okay, so I would suggest what you do is you take what you know over here, and you say x is less than 3 plus delta, and rework this so that it looks like that, and then you will see what how we will have to choose our delta. So let's take the 3 across. That becomes x minus 3 is less than delta, and remember here that x is bigger than 3, so this is positive. So let's see, we can divide. X minus 3 is 1 over delta, so we want that to be greater than, or we get that under this assumption, we get that this is greater than delta. So this is greater than 1 over delta, greater than 1 over delta. So this is greater than 1 over delta. And this follows from, let's say, since x is less than 3 plus delta. And if you rework this, you can get from here to there. Okay, and now we see here how we should choose our e, no, our delta to get e. So remember, we want to get this thing greater or equal to, and what do we want? We now want here to be a 7e. So let's just think, what should delta be to have this 1 over delta greater than 7e? So let us see, let's multiply by delta, divide by e. Delta, let's divide by 7e. So we want delta to be smaller than 7e. So if we bake in a 1 over 7e, 1 over 7e here, and we need our delta to be smaller than 1 over 7e, so we take the minimum of 1 and 1 over 7e. then actually over here, then delta is less than or equal to 1 over 7e, and since this is true, we get finally that this is true. So let's write here, since delta is less than 1 over 7e. Delta is less than 1 over 7e, then 1 over delta is greater than 7e. 7's cancel, and we are left with e. And we are done. Okay. And this is it for this example. I will see you in the next one.